Hi, my name is Bharat Kaladindi, and this presentation will be about how I tackled the COVID X-ray classification problem. So in 2020, the coronavirus has caused worldwide shutdowns, and in the US, cases continue to rise. Strong and efficient diagnostic tools continue to remain important in combating this, such as X-ray scans. You can see an example of a patient with COVID's X-ray scan on the right. While CT scans have a lower misdiagnosis rate historically, X-ray scans are faster, cheaper, and produce less radiation, making them more equipped for this situation. So we will be going over a X-ray COVID detection model that was built upon a prior model called Dark COVIDNet to be more on par with other gold standard models in this scenario. So within this area, several models have been proposed for both binary and multi-class scenarios. Multi-class scenarios would include COVID and healthy patients as well as patients with pneumonia, which would better reflect real-world scenarios. These models tend to follow the general template of image classification models. Many of them were types of CNNs with a large number of layers. One model of interest is the Dark COVIDNet model, which has a substantially smaller number of layers compared to the others we found. Dark COVIDNets make up of 17 convolutional layers and 5 maximal layers. The authors created these darknet layers where each convolutional layer is followed with batch norm layer to standardize the inputs and stabilize the model overall. Leaky ReLU is then used as an activation function. The authors structured the model in this way in the hopes it would optimize being able to learn small differences rather than just building a deep model. They based these ideas on an already successful real-time image detection model called YELLOW, which used DarkNet 19 as the backbone for classification. DarkCoverNet is a variation on this DarkNet 19 model, and DarkCoverNet performed decently in both binary and multi-class classification scenarios, but a newer version of YELLOW may provide a path for improving on these results. See, the newer version of Yellow uses DarkNet 53, which expands on DarkNet 19, and is similar in some of the previously discussed models in size. So DarkNet 53 still uses the DarkNet layers introduced in DarkNet 19. Because we're expanding on the prior model, we have to account for overfitting and the vanishing gradient problem that larger networks face. So DarkNet 53 incorporates residual blocks and skip connections. These blocks use two darknet layers and these skip connections and add the output from the prior layer to the layer head, providing the ability to train deeper networks without losing accuracy, as the residual makes up for that loss. Here we see the entire model, where we intersperse these ResNet blocks rather than using maximal layers, and this architecture matches some of the models we previously discussed. So our goal is to use this DarkNet 53 model to see if we can improve on the DarkNet 19 model and meet the standards of other state-of-the-art models within this space. For the experiments we run, we empower the dataset provided by the authors of CoroNet. It includes 4 classes, including subsets of pneumonia. The images have been resized to be equal size and resolution, and it already divided fairly evenly between classes and prepared for running training, validation, and testing experiments. In terms of dataset size, it compares well with other publicly available datasets as well. So our experiments will test 2 scenarios. The multi-class scenario classifying among all 4 classes, and the binary scenario looking just at code. We use PySpark to pipeline and preprocess the dataset and use a 70-15-15 split for training, validation, and testing. We replicate the Dark COVIDNet model as a baseline and use the results from CoroNet as well, since it represents another large model that was tested on the same dataset used here. The model was trained over 100 epochs within each scenario before being passed in the testing dataset. We first look at the results from the experiments in the binary classification scenario after training the DarkNet 53 model and classifying the images in our test set. And we see that it failed to meet the performance of either model across all metrics measured. Looking at why, it's clear that the model succumbed to overfitting. Looking at the loss curves, the training loss consistently falls, but the validation loss fails to stabilize until the very end. We also see that the classifications were split equally, but neither were improvements. The multi-class experiments were quite different, as Validation loss stabilizes much earlier and follows a similar trajectory as the training loss. We also see better accuracy across the various classifications as well. Comparing the results, we see that Darknet 53 outperformed Darkovnet in terms of accuracy and performed better across classifications, which is a positive sign that adding more layers to the model is a viable path for improvement. While CoreNet slightly outperformed in terms of accuracy, Darknet 53 seemed to do better in terms of classifying COVID. So it's clear that Darknet 53 would need modifications to account for the overfitting issue. There was some experimentation with adding dropout layers, which is a common way for combating overfitting. However, no meaningful changes to performance were found in that limited experimentation. But future work should explore more avenues for adding noise. A more popular way for dealing with overfitting is via transfer learning. This could involve pre-training the model on the ImageNet dataset and has historically been proven to be quite effective in this problem space as well. The relatively small dataset makes it easier for the model to overfit as well, so gathering more data would be useful. The deeper model also has a longer runtime, which limited testing possible modifications in this iteration of the project. So future work should involve using GPUs. Overall, based on the results in the multi-class scenario, it seems like implementing these adjustments in the future could place Darknet 53 as one of the gold standards in this space. And here are the works reference. Thank you so much for listening.